Hello everyone, my name is Amparo Lopez and I am full professor at Environmental and Hydraulic Engineering Department at Universitat Politécnica de Valencia. Today we will be speaking about digitalization and which are the digitalization pillars in the water engineering models. So when we finish, we will be able to understand this concept of digitalization in terms of water engineering modeling and the need of digital transition in these fields. And we will be able to identify the main pillars of digitalization for water and environmental engineering models. So we will be speaking about what is digitalization. Why should we introduce digitalization in our water engineering or environmental engineering models, the main pillars of digitalization, and finally the conclusions. In terms of water engineering and environmental engineering models, what is digitalization? Well, it is a process from what any water system can undergo to move from a traditional model, an analytical, a computational, or a physical model, inside an integrated computational representation running online, in which in any moment we will have calibrated solutions. So this digitalization must be included in our problem of water and environmental engineering model because solving these equations in these water engineering, hydraulic or environmental models involves solving thousands or even millions of nonlinear simultaneous equations. So the use of digital systems is very positive because we cannot solve this task manually or even we cannot solve that numerically. So digitalization will help us to do it quickly and to be able to represent several scenarios to take optimum conditions. So we have to manage a big number of data, each time more data with more series in water cycle and environmental aspects, and it must be considered in any moment. So digital transition will help us to do this task. The main pillars of digitalization are five in terms of remote sensing, on-site sensing, advanced modeling, artificial intelligence and machine learning, and digital twin. Let's go to any of them. Data, remote sensing, and Earth observation. In this case, data come from Earth observation satellites, which are very important to be analyzed in any sort of generating data process by experts. In terms of environmental or water modeling, we can have meteorological data, hydrological data, hydraulic data, fluvial, maritime, population, any sort of data collected in very short process of time. And it must be complemented with the on-site testing, with the data coming from measurements which are located with Internet of Things and in which we can take this information and bring them to the consumer. We can have at the same instant water level flows, flooding alerts, temperature, pressure, valves, water quality, water use alarms, many aspects in environmental measurements or water measurements which are very important to take decisions. The third pillar is advanced modeling. Advanced modeling is required where we have very complex hydraulics problems. And we will have a model very well calibrated, very well validated with series of data in considering uncertainty and sensitivity analysis. And we will have this model post-process to take decisions quickly when we have the nice information to come into data. Use artificial intelligence and machine learning, we will be able to have calibration of the data, cost effectiveness analysis, large management, and so these aspects of artificial intelligence will help us to precise the model. And the last, finally, objective is to have a digital twin. A digital twin computes all these aspects of digitalization, and it's a virtual model replicating reality, but who can, as an expert, analyze the many situations before they occur with calibrated online aspect on site moments and give us the best solution to take decision on time, giving us many simulations. So a digital twin is the final objective of this digitalization problem and these digitalization pillars based on the digital transition. So we can conclude that water and environmental engineering models are moving from a traditional approach to decision-making predictive, holistic approach based on digitalization. And we have these 5 pillars going on, finally, from the remote sensing, on-site sensing, advanced modeling, artificial intelligence, and machine learning to finally propose a digital twin integrating all this information. I hope this was of your interest. Thank you very much indeed.